Hello, my dear students. Assalamu alaikum. I hope all of you are fine. So, welcome back once again in today's lecture. Today, I'm going to talk about method of section portions of structural analysis. I have already covered what is trusses, what is method of joints, and how we can identify the zero force members, the conditions for the zero force members already. And today, I'm going to discuss about another important analysis of structural analysis, that is method of sections. So where we can apply this method of sections, actually when we need to find the forces to some specific portions, you can see here this is there is a truss here, and if in the question it is asked to find out the forces at this member, then it will be very lengthy process to apply method of joints uh, to identify the forces at that member. So in these cases, it's very wise or it's very beneficial to apply method of sections. It reduces the workload and simplify the solutions. So when we can so when we need to find the force in only a few members of a truss, we can analyze using this method of sections. Okay, so this is basically follows the principle of equilibrium, right? All right, so it is based on the principles of equilibrium of forces, to be honest. Okay, so now let me explain how. Okay, so actually if this structure is in statically in equilibrium position, it means all the members that is available in this truss, they will also be in equilibrium positions. All right, so let's say let's take a member from this truss. Okay, and if we consider that this member is in tensions, right? All right, that means we need to show that the forces, tension forces, with the arrowhead like this, right? So now if I make a cut section here, at that time there will be two members, right? And to make it in equilibrium, then there will that the force that was acting internally here, that will act externally uh, here to make the system in equilibrium positions. Okay, do you understand? Think a little bit. I think you'll understand. Okay, the same explanation goes for compression as well. If the member is in compression and if I make a cut from here, okay, the force that was acting internally in these sections, it becomes an external force when we cut it, okay, to make the system in equilibrium positions. All right, so if a member is cut into two sections, the internal forces are exposed. Now becomes the external forces that the thing just I have explained. So uh, after that, the method of sections can also be used to cut or section the member of an entire truss, right? So also we can use, actually I am in the theory sections. When I will solve some problems, then it will be much more clear to all of you. Okay, so if the section passes through the truss and the free body diagram of either of its two parts is drawn, we can then apply the equations of equilibrium to the to that part to determine the member of force at the cut sections. All right, so it means that we can apply the equations of equilibrium after we cut the sections to determine the forces that is acting inside the members. Okay, now we should try to select uh, a section that in general pass through not more than three members in which the forces are unknown. Actually, to make it simplify, okay, so if we have a truss, okay, complex geometry, we need to cut the section in such a way that there is not more than three members. Why? If there is more than three members, let's say if I let me explain from here. Okay, so you see here there is a the pin joint here, right? So there will be two unknown forces, reaction forces, okay, and there is three member here, okay. So in total there will be five unknown forces if I make a cut section from here. Do you understand? Okay, so I cannot cut from here, although if I need to determine the forces that is acting in FD, I will not cut it from here. All right, so I will cut, I will maybe I will cut from somewhere else. All right, so it will not be a wise idea to cut it exactly from here. All right, so we need to cut from such a positions where there will not be more than three members. Okay, if there is three members, we can somehow manage to find out that forces that is acting there. Okay, how? We have three ways to do it. There is summation of fx is equals to 0, summation of fy is equals to 0. That means the resultant forces in x direction and resultant forces in y direction is equals to 0, and the rest is moment. So these are the three equations we have. We need to apply these three equations to identify all the unknown forces that is acting there. All right. So now what are the procedure of analysis this kind of truss? Okay, so at first you need to decide to cut the truss, from where you will cut the truss. Okay, so decide how you need to cut the truss. This is based on number one, the two criteria is there, where you need to determine the forces. This is one, that means the unknown forces that is asked to you to determine, and number two, where the total number of unknowns does not exceed 3, that I just explained. Okay, number two, decide from which side of the cut truss will be easier to work. Okay, so if you cut, there will be two section, right? There will be two sides, right? So you need to select the truss in such a way that your solutions become easier. Okay, so you need to choose that portions. If you cut a truss, there will be two sections, so you need to select the easier sections. All right, so if required, number 3, if required, determine any necessary support reactions by drawing the free body diagram of the entire truss and applying equilibrium equations. Actually, not if required, it will be required. Okay, so I should change that one, that word. You need to find out the reaction forces if there is any available. Okay, if there is any support in the truss, at first you need to find out the unknown reaction forces, because definitely you need to find out you need those reaction forces while you will solve the uh, equations to determine the unknown forces. All right, so this was the first step of our method of joints. If you remember that we have to find out the reaction forces that is acting on the truss. Okay, then we move to the solutions. So again, here we also repeat the same thing. Okay, so now draw the free body diagram, that is the FBD diagram of the selected part of the cut truss. Then you need to indicate the unknown forces at the cut member. Initially, you may assume all the 4 members are in tensions, as done when using the method of joints. Okay, so actually when you make the sections, you can assume all the members are in tensions. Okay, as I as I mentioned earlier, that if you just assume all the members either in tensions or in compressions, there is no wrong or no right assumptions for here. Okay, so when you will get the results, you will know whether it was your assumption was correct or it was not correct. All right, so you are free to assume, no problem. Okay, sorry, yes, here. Okay, now the point number 5, that apply the scalar equations of equilibrium, that is EOE, equations of equilibrium, at the cut sections of the truss to solve the unknown number of forces. Okay, so this is the way. So actually here, at first I have let's say I have assumed that I will make a cut section from here. Okay, Now I have two options. Either I will analyze the forces on the left hand side, this side, this one, or I can choose this one. Okay, so you need to choose that one based on your necessity. Okay, and based on which one is easier for you. Okay, then you need to draw the free body diagram that is acting here. Okay, so you can assume initially that all the members are in tensions, or all the members are in compressions, or you can also assume a mixed mode of assumptions as well, no problem. Okay, and when you will get the results, then you will realize, or you will know, identify whether your results was whether your assumption was right or wrong. Okay, all right, so this was the basic theory of method of sections. Okay, so now let us solve some of the problems to make our concept clear. Okay, let's start with the easy one. Okay, so example number 5. Okay, so determine the force in member GE, then GC and BC, right? So it asked from you to determine the force in this member GE, then GC and then BC, these three member, right? So at first in the question you make a mark, yes, GE, then BC, GC, then BC. Okay, so I think the force is asked in such a way it's make easier for you to make a decision from where you need to make the cut sections, right? So if I make a cut section from here like this, okay, so it will make easier, it will be very easy for me to find out all the three unknown forces, right? Okay, but here we can see there is a pin joint and there is a roller joint, okay, in these two portions. So here there will be two unknown reaction forces and there will be one unknown reaction forces. So as I always mentioned, this point will be same for method of joints and method of section. At first you need to find out the unknown reaction forces in the truss. Okay, so this will be our first task. Okay, so I will draw the, you need to draw the free body diagram. I don't have the scope right now to draw it. Okay, you will draw the free body diagram at first, okay, of this structure. Okay, then you will find out the unknown reaction forces, then we move forward. Okay, we'll cut the sections. Okay, so first thing first, so this is the free body diagram. Okay, showing all the reaction forces that is acting here and here. Okay, so we have three equations and I think it's pretty simple and straightforward. Okay, so there is there is in x direction there is just two forces. So if we resolve the forces in x directions, we'll get the unknown force ax, and ax is 400 newton. So the directions is correct, right? Now we have another two unknowns, ay and dy. Okay, if we take if we resolve all the forces in y directions, it will not give us the result. Why? Because there is no other equations to get it. So what we have to do, let's take a moment first at any of the point, at A or at D. So let's take at A. Okay, so if I take a moment with respect to A, then it gives us, so, and if we take the anti-clockwise directions as positive, that gives us, so we are taking moment with respect to point A. Okay, so this is the force 1200 newton. So if I want to connect this 1200 newton force with A, so I need to come in this way. So it is clockwise directions, but as we assumed anti-clockwise direction as well positive, so it will be negative, that is minus. So minus 1200 multiplied with the distance, that is 8 meter. All right, so again same thing goes for 400 newton forces. So if I want to connect this 400 newton with A, I need to come in this direction, that is clockwise directions. So it is also, this force will be also negative, so minus 400 multiplied with 3 meters. This is the distance, okay, perpendicular distance. And for dy, it's pretty simple. So 8 plus 4, that is 12 meter. So if I solve it, then you will get the results. Dy is equals to Okay, now if we just resolve the forces in y direction, then we'll get the another unknown forces, that is ay is equals to 300 newton. All right, fine. So now we have the reaction forces ax, ay, and dy. Now we will what is the next step? Then we'll make a cut sections. Okay, so we have as you can see here, we make a cut sections like this. Okay, now we need to determine the forces. That is FGE, FGC, and FBC. Okay, to do so, you know, how we can do so? As you can see, at point G, there is lot of unknowns like 1, 2, 3, 4. Okay, so if I take a moment at point G, then what will happen? We can easily find out the other members, other one force, that is FBC. Okay, easily. So taking a moment with respect to point G and taking anti-clockwise direction as a positive one. Okay, which gives us, so this is our first force, that is 300 newton, and this is our point G. So if I want to connect this 300 newton with G, I need to go in clockwise directions, right? So it will be negative minus 300, and this is the distance from G, that is 4 meter. Okay, then the second force is again 400 newton in its negative directions. Again, if I want to connect this 400 with G, I need to come in this direction, which is a clockwise direction, so it will be negative. So minus 400 multiplied with 3 meters. Okay, and the another force, that FBC, we have assumed that this is acting in this direction. So if I want to connect with G, I need to go in this direction, so it will be positive, that is the clockwise direction. Anti-clockwise directions multiplied with the distance, that is the 3 meter. All right, so we got one unknown already, that FBC is equals to 800 newton. Okay, now what we can do, uh, now you have a couple of options, but resolving the forces will make much more complex problems. So that's why we are taking a moment at point C. Okay, so now if we take a moment at point C, what will happen? So FGC, this one, and FBC, these forces will be vanish. All right, so let's take a moment at point with respect to point C, right? So minus 300 newton, minus 300 multiplied, this is the 300 newton force multiplied with 8 meter distance. Okay, from point C, it was given in the questions. Then FGE, this is the force, and the distance is 3 meter, right? So these are the forces that is acting here. Okay, in this cut section, these are the forces it is acting. So FGE is equals to 800 newton. These are unknown forces. So now if we just resolve the forces in y directions, there will be, we will get one unknowns. Okay, there is just one force 300 newtons, and one force FGC here. Okay, so 300 newton minus 3 by 5 FGC is equals to 0. So from here we will get the result for FGC, that is 500 newton. Okay, so now we have easily solved these three unknown forces, FBC, FGE, and FGC. Okay, so in this way we can find out these unknown forces to a structural structure, okay, easily by applying method of sections. Now let's solve another problem. It's interesting. Okay, so determine the force in member CF. Okay, so it wants from us to determine the force at CF. Okay, indicate whether the member is in tension or in compressions. Okay, assume each member is pin connected. Okay, so yes, definitely we need to assume that one, it's pin connected. So at first we need to draw the free body diagram, and we need to identify the reaction forces. Now one question for all of you, can you identify any external forces in x direction here? I think the answer is no. There is no external forces in x directions. So from here I can easily say that the support reaction at A will be just in one direction, that is the direction y, right? In x directions it will be 0, the reaction forces, right? So this is your task you will do, okay, and you will identify the reaction forces, okay. So it's done for you here, okay. There is no external forces in x directions, as I mentioned here, the reason as well, okay. So now what we are going to do, we are going to make a cut sections from here so that we can identify the force, unknown force, that FCF here, okay. So now to do so, actually there is a couple of way to do so, okay. So at first we can I have solved it in another way. Let's solve it at first in this way, okay. So how we can do this, as you can see, this member is not a straight member. That means, so this will, if we make a extension over here, so it will come up to this, right? That is done, that is shown here, right? So what is the reason to do this? Because if we take a moment with respect to E, we cannot take this force as 0 because it will not pass to point E. All right. So that is why we need to consider where it goes. Okay. So now our concern or our goal is to find out the force at this member, that is FCF. Okay, how we can do this? Okay, to do so we need to find out at first the distance from here to here. Okay, what is the distance of x? Okay, so it is actually, if you go to your book and page number 227, you can see the how it is done. X, the value of x will be 4, but let me explain. This is a very simple concept. I think all of you have done in your secondary. Oh sorry, I think it's not. I think now you can see, right? Okay, now you can see. Okay, so here so actually this concept is for similar triangle concept. Okay, as you can see, this is the triangle. Okay, so if we take two triangle, one is the big triangle, and if we take the smaller triangle, okay, by taking the ratio, okay, of these two triangle, we can easily identify x is equals to 4 beta. Please go through your textbook to see the solutions how we have done this. Okay, it's very simple calculations. Okay, so now it's done. Now if we take a moment with respect to point O, what will happen? You see that if g, this force, it's g, it's going to be 0. Okay, then there is no other unknown except this, right? There is all the external forces is calculated and there is no other unknown. Okay, there is one other unknown, FCD, but that will also be 0 because it passes through this point, right? So this will also be 0. FCD will also be 0. So we have just one unknown, FCF, and we can easily identify that one. Okay, so just let's take a moment. Let's take a moment with respect to point O. So minus FCF. So minus FCF. So this force, okay, translate this force at this point. So one force will go in these directions, right? Okay, and will one force will go in x directions, one component, and other component will be in these directions. Okay, so we need to consider which component. Can you tell me? Okay, uh, anyone? Okay, so FCF. Okay, yes, if you this force, okay, FCF here, no one sorry, actually I forget, I'm not in live classes. Okay, so FCF will have one component in these directions, another component in these directions. Okay, x directions in these directions, another component in these directions, right? FCF. So in FCF, one x direction, this x directions, what happen will do? So x direction, it will passes through this point and it will be 0. And another force, okay, if we consider, okay, as we have considered that it is in compression, that's why the force origin will be from here. If we consider its in tension, then at that time it will be from here. The force will come from in this direction. At that time you need to consider in this way and this way. Okay, keep it in your mind. So as you have considered compressions, we need to assume that this force is here. If you consider its in tension, then the force will be the origin will be from here. Keep it in mind. So FCF, so this direction, so we have taken clockwise directions in positive direction. So but this FCF in this direction, if you want to connect, we need to go in clockwise direction, so it will be negative minus FCF, and for sure it will be sine 45 degree, and the distance will be 4 meter plus 4 meter and plus 4 meter, that is 12. What are the other forces? 3 kilonewton. Okay, again same rules. 3 kilonewton it's positive and 4.7 kilonewton it's negative. Okay, force multiplied with distance. If you just do this, you will get you have just one unknown and you can easily identify FCF. You just see how easy it is to apply method of sections uh, to identify some unknown forces to a specific member. Okay, we don't have to, you don't have to find out all the forces that is acting each and every members. Okay, to find out these forces, you can easily find out using method of sections, and this is the beauty of method of sections. Okay, so I think you understand this now. Actually you could ask, sir, yes, we could solve this problem in other way. Yes, you could, and I have also tried this one for you. Okay, actually here I have explained it, these figures more clearly. Okay, so you can have a look here, so how we have taken the moment with respect to point O. Okay, and just I'm giving one more time reminding you, this is the big triangle. Okay, so we can write 6 over this arm 4 is equals to 8 plus x over 4 plus x. Okay, so if we just solve these equations, you will get the unknown of x by applying similar triangle rules. And the moment, how we have taken the moment, I have just explained. So this is how it is. Okay, now we can solve this in other way. How we can do this? Okay, to do this, let's say you need to find out the angles. Okay, this is I just calculated by rough paper. Okay, you just have a look. Okay, so we have all the members. Let's you can identify this angle and this angle as well. And after that, if we take a moment with respect to f, okay, actually I have solved the solutions, roughly. Okay, if you try to, and you try to solve the problem in other way, apart from these solutions, you will get the same results. I have also got the same results. Okay, by taking moments in it's my own way. Okay, so if as long as your procedure is correct, there is no problem. You will get the right answers. Okay, uh, if you are confident what you are doing. Okay, so this is other options you can solve it. Okay, you also try to solve it in other way. Okay, let's try to solve one more problem, article number 6.7. So determine the force in member EB, that means in this member, okay, of the roof truss. It's a roof truss. Okay, the roof truss indicate whether the member is in tension and compression. So it's simple. So there is actually no support. Actually there is the reaction force is given 400 and 200 newtons. So let's jump into this. Okay, so to do this, what we have to do, we need to find out this member in EB. So what we will be doing, we'll take a cross sections in this way. Also you can take it in this way as well, but it's same, it's symmetry. Okay, so let's take a cross sections in this way. Okay, and identify all the forces that is shown here. So one force will be here, one force here, one force here, and one force here. Okay. So now what okay, so now taking why we're taking a moment with respect to point B. Let's see, if we take a moment with respect to point B, you see all the forces FAB, FFB and FEB, all the forces become 0, and we have just one unknown, that is FED. So we can easily identify this force first, okay, then we can move forward, right? So the first target, okay, we have already identified that FED, okay. So by applying the moment at point O, I think if you just go through it, you will understand how it is applied. Just let me explain a little bit at point B. So these three forces will be 0. So what are the other forces we have? That is, we have 1000 kilonewton, and the distance from here 2 plus 2, that is 4, right? So in this direction I have to go, so that is the anti-clockwise direction, so it's positive. Then we have another force 3000 kilonewton, so in these directions again it will be positive. Then we have another force that is 4000 kilonewton, and definitely it's going to negative, it's going to be negative. So, and the distance, and plus the another force, this is another force if ED. So FED, so as we have considered this is the compressions, okay, so we need to consider the origin of that force. So one force will be in x direction, other force will be in y directions. So x direction force passes through point B, so it will be 0. But if ED passes through point D in y directions, vertical y direction, so it will have a distance from point B, it's not 0. Putting this value, force FED multiplied with the distance 4 meter, which gives you the value for FED, that is 3000 Newton. So we have the value for FED right now with our hand, but the problem is not solved yet. So what we can do to do so, we can make again a cut section here in these sections, right? We can make a cut sections here, but initially if we make a cut section here, it was not possible. Why? Because there will be 3 unknown, and there you don't have any base to start. So that's why now we have the value for this one. Now we can make a cut section in this section. So now if we make a cut section here, and if we just resolve the forces in x and y directions, we can easily find out the values, right? So let's just do this. So if we just do this, I think it's pretty simple and straightforward. There is nothing complexity in x directions. If you resolve this one in x directions, this is completely in vertical position, so it doesn't have any component in x directions. So FEF, and the angle you need to find out from, it's given 30 degrees, so this angle will also be 30 degree, okay. And the answer, we assumed that here it was in compression, so it was in compressions. And again, if you resolve the forces in y directions, okay, so we will get that FEB is equals to 2000 kilonewton, okay. So I think with this I would like to conclude today's class, and we will continue from here. I will give a post of our next class in the Google Classroom. So till then, stay good. Thank you very much.